Hi guys, welcome back to lesson number 13. Right now we're talking about total chains, more specifically rectilinear motion, and we're starting out with question number 9. We talked about distance, displacement, total change, and now we're really getting into just kind of reviewing and just more practice questions. So most of this video, I'm not going to do the problems. The answer keys are on Schoology for you. I am just going to set stuff up for you and kind of talk about it so you guys get a little feeling for it. Most of you guys probably already know what to do for these questions anyway, so it's just nice to just kind of let me talk about it. If you're looking at the answer keys and you're like, oh, I don't know what I need to do, well, let's just talk about what it is. So we're keeping with our notes. We're going straight through them. It says the particle moves along the x-axis so that its velocity at any time where t is greater than or equal to 0 is given by that function, v of t, the quadratic. The position of the particle at time t equals 2 is x equals 5. So find a polynomial expression for the position of the particle at any time. So you guys know very well right now that if I were to integrate v sub t dt, right, so I'm going to integrate this. And so I'm going to integrate this problem right here. So the integration of 3t squared minus 5t minus 2 dt, I would get t cubed minus 5 over 2t squared minus 2t plus c, right? And that's going to give us our position function. It's some value. Well, all we have to do now is when we plug in for t, right, we're going to plug in for t, so we're going to get s of t, where t is 2, we're going to get 5. So we're going to plug in 2 here, we're going to get 8, we're going to get 5 over 2 times 4 minus 2 times 4 plus c, and we're going to get that c is equal to 11. So write a polynomial expression. We're going to go ahead and write down that s of t is equal to t cubed minus 5 over 2t squared minus 2t plus 11. All right, so that's our expression for any position at any time t. It says find the displacement of the particle from time t equals 0 to time equals 4. So the displacement of the particle. Notice again, it's not the final position, it's just asking for displacement, right? Just for displacement. So for this problem, for displacement, we're going to integrate from 0 to 4 of just our velocity function, d of t. And so we've actually integrated this, right? We actually already know what this is. So it'd be xt cubed. So this is why, again, these questions are given to you, and we would read with you. So if this were an, some question here, then maybe we would read with you here. This problem, and then we're going to evaluate this from 0 to 4. Okay, and so again, when you do that, you get 16. You get 16. Well, there was another way to do the problem. So I know some of you guys have been thinking, what if we done this? What if we done s of 4 minus s of 0? Right? So what if we did that? Well, yeah, we already know what s of t is now, so we could absolutely plug in s of 4 here, and then minus s of 0, and yes, we would also get 16. So this is another way of showing that this is just simply equal to this. So both of those ways are fine. I'm just cautious that if we make a mistake here, then this answer would be wrong. Again, we would read with you, so we'd give you credit for the work, but again, just be careful of the fact that we didn't make a mistake in that problem. All right. And then the final question says find the distance of the particle as we move along from time equals 0 to time equals 4. So guys, this is where we have to spend a little bit of time. So hold on for 1 second. Okay, so I went ahead and wrote down our velocity function right here so we don't have to keep going back and forth for it. So this is a non-calculator question. So with the non-calculator, remember we want to find the integration from 0 to 4 of the absolute value of our velocity from d to t. Now guys, I will tell you that 9 times out of 10, the question on the BC exam, or the AB exam actually on there, is not to solve the problem, but they want you to write an integral that shows you this answer without an absolute values. So what you're going to do here is you're going to figure out where my velocity is equal to 0. And so we're going to set our velocity function equal to 0, and we're going to factor, and you guys will hopefully understand here in a second what I'm about to do. So then I'm going to go ahead and factor my functions. And again, we look at time is equal to 2, and yes, time is equal to -1/3. I don't care about that. So we know that our velocity changes signs at time equals 2. So let's again figure out what's happening at time equals 2. I'm going to go ahead and bound this at 0. So if I plug in, let's say 0, let's plug in 0 here, then I'm going to get a positive, and I'm going to get a negative. So I'm negative here, and then I'm going to be positive here. So what this is saying is that if I were to physically graph this function, if I'm going to graph this function, this v of t function, then from 0 to 2, it's going to be underneath the x-axis. And then from 2 to 4, or 2 to infinity now, it's going to be above. So if I want to rewrite this, without using any absolute value, what I can essentially do then for this problem is just write the integration from 0 to 2 of v of t dt. Now remember, this value is going to be negative, so I need to put a negative in front of it. So now that's going to change this to a positive value, because this value right here, the integration from 0 to 2 of v of t dt, we already know that velocity is negative there. So all I have to do is put a negative in there, and so I can now integrate this by hand if I choose to do so, and then I just have my negative. And now I can do plus, and then the integral from 2 to 4 of v of t dt. And I know this is going to be positive. Let me get rid of this little graph thing right here that's bothering me for a second. So I can go ahead and now go from 2 to 4 and just go ahead and integrate normally, because I know this value is going to be positive. So this is going to be the setup that you do for this. And this is normally where they want you to stop it, because then it gets tedious. Now you're going to have to integrate this, which we've already done. And now we want to plug in 0 to 2 in this function. And here we want to plug in 2 and 4. And it all becomes crazy. And then the final thing is that when you do all that work and the answer key has it all, your answer is going to end up being 28. Okay, so then you just go to the fundamental theorem of calculus. But just don't forget that when you're finding this value right here, and I would find it normally, you just want to, whatever that number is, you just change its sign. You just change its sign. And so I just will tell you guys really quickly that this is going to end up being -6. -6. So you're just going to basically, make it +6. So this ends up being 6. And this ends up being 22, if you guys actually look at the word for it. Okay? All right, so this is one time where if you were to do the distance question without a calculator, right, this is a non-calculated question, then you will have to think about where my velocity is equal to 0, figure out where the signs of the velocity is, and then you would have to just change the sign of the integral there. And I will tell you that this is what I would expect you guys to do. I'm not going to have you, there's no reason why you would have to go and do all this work, right? It's silly, especially because you have a calculator, right? You have a calculator. So that's what I'd be looking for. Okay, so let's move on to the next question. Okay, so question 10, I'm not going to do at all. I mean, it's kind of another practice question that we've done before. We're given the velocity function. We're telling you, the position at x equals -3 is 2. So you integrate velocity, you do the plus c, you'd find the c based on the information right here. So you get your position function, and then you'd plug in 1. Okay, you plug in 1. So the answer ends up being 2. Okay, so the last question that I love is this one, because there's multiple pieces to it, and it's awesome. So there's a lot of them. So we're going to use this somewhat decent graph. And what I wanted to say is that this question, is just very good as far as like an FRQ would be. And we chose a lot of possible choices for you guys to be asked questions about. So this is really good. The graph to the right shows the velocity. So again, we want to focus on the fact that it's a velocity function, which is amazing, of the particle moving along the x-axis on the interval from 0 to 11. It consists of a semicircle and 2 line segments. This is very common. This is very common in FRQs, especially when you're given a graph. Even though it's common sense, it wants you guys to know that this is actually a semicircle. So you could find the area under the curve knowing this is a circle, true semicircle, and then this right here is just 2 straight lines. Use the graph in your knowledge of motion to answer the following questions. So a question, letter A, it says at what time t from the interval from 0 to 11 is the speed of the particle the greatest? So remember that if we're looking at this time, so any point, we talked about this in the particle motion stuff, that every point that's on this graph, time, and it's going to be velocity, right? So we're looking at the y values here. Y values here. Let me put that as parentheses. So what we're looking for is what is the highest value of velocity if we also take into account that's the absolute value, because speed is actually the absolute value of velocity. So here our speed is 2. Here our speed is 3. But way down here our speed is actually 6. Right? Our velocity is -6, but our speed is 6. So let's look at where it actually is 6. And so it's right here at time equals 8. At time equals 8. Okay? So that's it. And it doesn't say just for our answer for that one, so this is just one where we just say that at time equals 8. At which times time equals 2, 6, or 9 is the acceleration of the particle the greatest? So where is the greatest? So we have to remember, ladies and gentlemen, that if we look at 2, 6, and 8, or 9, the acceleration is the greatest when my velocity is increasing the fastest, right? And so more so to that fastest. Oh my God, I had a brain fart about how to spell the word fastest. Where VT is increasing the fastest. So basically, where's my slope? The largest is really in the algebraic terms is where is the slope the largest. So at time equals 2, our velocity is 0, right? So at time equals 2, our velocity is actually equal to 0. So we know that's probably not right. At time equals 6, our velocity is actually negative. Again, we don't care what that value is. It doesn't ask us what the value is, but it's just going to be negative. So our velocity is going to be less than 0. So at time equals 9, our velocity is going to be greater than 0. So our answer is going to be at time equals 9. And again, our justification is that our velocity, first of all, we could say our velocity is greater than 0. It's the only one where it is, right? This one's negative, this one's equal to 0. It's also that our velocity is increasing the fastest. Again, please stay away from slope. Okay, on what intervals is the particle moving to the left? So now we're getting back into stuff what we've done in the previous lessons with particle motion. So where is it moving to the left? Well, you guys know this, but again, it's a good way to justify our answer, right? Why do we justify our answer? So we're moving to the left on the intervals from 4 to 10. So I'm going to go through this one very quickly. So hopefully you guys answer these questions before I answer them. So you can always pause the stuff when you guys get to the next question. It's 4 to 10, and the reason why is that velocity is less than 0. Okay, again, we don't want to say it's underneath the x-axis. We want to say velocity is less than 0. So that's all that you write. That's all you have to write from 4 to 10. So it's forward here, forward moving. We're moving backwards, and then move forward again. On the what time intervals is the speed of the particle decreasing? Is the speed of the particle decreasing? So guys, what this means, and it's just another way for it, and again, I hope you guys already know this, it just means where is it slowing down? Right, where is my particle slowing down? If my speed of my particle is decreasing, then I'm slowing down. So that means that my velocity and my acceleration have to have different values. So from here to 0.2, my velocity is positive, and so is my acceleration, right? I'm going up, so it's going up. So from 2 to 4, velocity is positive, but my acceleration is negative. So our first interval is going to be 2 to 4. And now from 4 to 8, again, they're both negative, right? Velocity is underneath the x-axis, and our slope is negative. Then from 8 until 10, right? 8 until 10, we're going to have a positive acceleration, but our velocity is still negative. And then we're both positive, again, from 10 to 11. So it's going to be from 2 to 4 and 8 to 10. And our justification is that our velocity and our acceleration have different signs. Okay, have different signs on those intervals, right? On these intervals. Okay, on these intervals. All right, so again, a little blast from the past in that question. Let's look at question number E. So find the total distance traveled by the particle over the time interval from 0 to 11. So this is, again, going to be a good question. Yes, total distance. So what we want to do here, ladies and gentlemen, is we want to find the area of this, and we want to find the area of this. Remember, we're going to keep it positive because we're looking for total distance, and then we're going to find the area of this. That's all we're going to do using algebra. So while we actually have the problem up here, we can look at this. This is a semicircle. So we know it's going to be pi r squared divided by 2. Our radius is going to be 2. So we know that this is going to end up being 2 pi. So we know that the semicircle is 2 pi. For this next part right here, and notice that these are very easy shapes to do, and that's what's expected in these problems. We have 1, 2, 3, 4, 5, 6. So it's going to be 1/2. Our base is going to be 6. and our height is going to be -6. So let's just keep it positive right now because again we have we're looking at the distance. So we have 18 for this answer, and then this little tiny little triangle right here, we have 1/2. It's 1, and then the height is going to be 3. So that's going to end up being 3/2. And so this answer is going to be 2 pi plus 18 plus 3/2. And so our total distance, now again, sometimes what they want to do is they want to see the equation. They want to see the equation. So we want to show that. We just don't want to start writing these numbers down. We want to justify why we're writing that, what we're doing here. So one of your points would simply be to write the integral from 0 to 11 of our velocity dt. And now we can start adding what we want here. So it'd be 18, and then we would do plus 18, which technically it's a -18, but then we're adding it with the absolute value of it, so it would be that, and we get 3/2. If this is an FRQ, ladies and gentlemen, this is a fantastic, fantastic answer for us. But if we want to just go ahead and continue out, which we do not need to do, I'm stressing that right now. I'm actually going to box this one in because this one's better. If it's FRQ, that's great. That's a fantastic answer right there. There's no reason why we need to combine the 18 and 3/2, even though it's pretty easy to do. Okay, so that's going to be our function for this. So if you guys look at how we wrote E, and now the question says find the value from 0 to 11 of our velocity and explain the meaning of the integral in the context of the problem. So hopefully you guys realize that this is going to be our displacement, but we want a little bit more than that, right? We want a little bit more than that. But before we get to our description, we've already done all the hard work. Again, ladies and gentlemen, this is where we would read with you. We'd read with you. So if one of these numbers were wrong, if you wrote them down here, we would still give you the credit for the work for this one. We are not going to penalize you twice. But the only thing is that remember up here, we want this to be a -18, right? So we're going to subtract 18 plus 3/2. So that's it. Again, that's the better answer. That's going to be their better answer here. But that's going to end up being 2 pi minus 33/2. Okay, and so really what this means is that this is the total change, and you could write displacement too, but it's the total change of the particle, and this could be if it's where it is. I would say total change basically of its displacement. I mean, that's really what it is of a particle, but you can get very vague with these, and it's okay because it's a total change. It's an integration, total change of the particle on the interval from 0 to 11, and we can also say that this is, again, the displacement. The displacement of the particle from 0 to 11 is also a fantastic answer for this problem. Okay? And then part G is if the initial position of the particle is this, find the position of the particle at time equals 11. And again, we've already done all the work for this problem, right? So all we have to do now is say that our position, and again, I'm going to use S, it doesn't really matter, of 11 is going to be equal to our initial plus our total change. And so we're going to just go ahead and say it's 2 plus 2 pi minus 33/2. And that's the only additional thing that you have to do here for this question. And so it's going to be 2 pi minus 29/2. Yes, you could also do 2 pi minus 18 plus 3/2 plus 2, and you could also do that as your answer. So that is going to be our problem for that. Okay, I think that's a good stopping point for this video. So hopefully, again, this makes sense to you guys. We did a little bit of a blast from the past here, so now I can ask you guys a lot of questions about this graph, especially if I'm giving you the velocity function. Okay, so I will see you guys in the next video.